All right, Math 1, evaluating function notation. So function notation is one of those things that sometimes annoy people, sometimes people like it. It can be kind of neat if you understand what you're doing, but let's first talk about this. Function notation means that if you'd normally have like a function y equals, let's just say 2x plus 3. That's a line. We could rewrite that as f of x equals 2x plus 3. And what this means is f is the function name, or the function label, maybe would be a better way to say that, but we're going to stick with name. And then this tells us what the variable is. What is the variable? VAR. What the variable is. So, still working on our scratch work up here. If I were to rewrite this guy as f of, I don't know, we'll say f of h equals, well, I've just changed my variable. My variable was x, but now it's h. So I'm going to have to rewrite this as 2h plus 3, right? All that's in there tells us what is our variable. Now, similarly, if I decide that I want to find, or I want to say what is f of, we'll say 2, f of 2, well, that means that we need to put a 2 anywhere that there was a variable. So we're going to say 2 times 2 plus 3, which gives us an actual numeric answer, 4 plus 3, which I believe is 7. 4, 5, 6, 7. Yes, 7. So if we were to write that in function notation, we could say, well, f of 2 equals 7. And what this statement here means, if we were to read it literally, it would say the function f evaluated at 2 equals 7. So another way to say that is the function f, after you plug in a 2, equals 7. Okay, so it's a different way to talk about it. Now, this can be useful whenever you have multiple functions. So say you had like 3 different lines, you could label them as f of x, g of x, h of x. And I think I just used some verbiage there that I might have not gone over. Whenever you have, look over here, that f with an x, you normally say f of x. That means f and then parenthesis x, f of, like of OF. All right, so let's see how this would work. Let's look at number 1. So number 1, we tell us that we have a function h, the variable is n, and then it is equal to negative 4n minus 2. And the problem says evaluate or find h of 0. What that means is plug in a 0. So we're going to rewrite this as h of 0 equals negative 4, and we put in a 0 there, minus 2. So this is equal to 0 minus 2, which is equal to negative 2. So if we were to write this at the end, we'd say h of 0 equals negative 2. There we are. Number 2, find h of 7. So this is a different problem, and this can be kind of confusing sometimes because they both used an h here in the beginning. But because they're different problems, you can just treat them as completely separate scenarios, okay? So we're going to plug in a 7 for our n. So I'm going to say h of 7 equals 2 times 7 minus 2, which is 14 minus 2, which is 12. And then to finish off, I'm going to write, well, h of 7 equals 12. And again, if we were to read this literally, what this says in math words, this says the function h, plug in 7, and you get 12, right? All right, let's look at the next one. Number 3, there's our h of x. See, our variable is now x. There's our x. And we want to find h of negative 4. So we're going to plug in a negative 4. So h of negative 4 is going to be negative 2 times negative 4 minus 1. Negative 2 times negative 4 is going to be positive 8 minus 1, which is 7. So I could write h of negative 4 equals 7. And again, I'm saying h of, here, let me write that. H of negative 4. That's how you would read that out loud. All right, number 4. We have another function h. Our variable is x, and it tells us that we want to plug in 3. So we're going to say, well, h of 3 equals 4 times 3 plus 2. This is 12 plus 2, which is 14. So h of 3 equals 14. All right, that's number 4. Let's go on the back page. The back page is just as easy as the front page, except now we're going to have some fractions. The fractions, we can type those in our calculator, and we're just fine with it. I just want us to be more comfortable with fractions. That's why we have these here. So we have a new function letter. It's g. Our variable is t, and they want us to plug in negative 11 ninths. So we're going to have g of negative 11 over 9. And normally whenever I have a fraction with a negative, I end up going ahead and putting that negative in the numerator because I find that I don't lose the fraction or lose the negative as easily if it's in the numerator. So g of negative 11 over 9 equals 3 halves times, and this is an aside, almost always whenever I plug into a function like this, I put whatever I'm plugging in into parentheses. There's ways around doing that, but I think that it helps me make less errors on my own. So I would suggest doing it this way. So we plug in negative 11 over 9, and then we have plus 1/3. So this is the same thing as, I'm going to combine some terms here. I'm going to say negative 3 times 11 over 2 times 9, just to put that negative out front, plus 1/3. I'm going to try to cancel some things here, and you could just type this all in a calculator, but I'm just going to try to do some of it in my head. I'm going to try to cancel the 9 and the 3. That gives me a 1 and a 3. So I have negative 11 over 2 times 3 is 6, plus 1/3. If I were to get common denominators, I would have negative 11 over 6 plus, well, how do I get common denominators of 1/3? I would multiply by 2 on top and bottom. So that's plus 2 over 6, which is negative 9 over 6, which can reduce to negative 3 over 2. Cool. So now to finish up the problem, I'm going to write my answer as g of negative 11 over 9 equals negative 3 over 2, or negative 3 halves. All right. Number 6. So we're back to our function letter h. Our variable is x, and it wants us to plug in a 1. Now something new with this problem, we have an x squared term in there. So we need to remember that we're going to have to square it. With this one being plugging in 1, that's not going to be very exciting, but later on that might be more important. So h of 1 is going to be negative 1/2 times 1 squared minus 3 halves times 1. This is going to be negative 1/2 minus 3 halves. Oh, wait, I wrote something wrong here. This is negative 1/3, and I wrote negative 3 halves here. I'm not sure why I did that. Let me fix this. This is negative 1/3. I apologize. There we go. All right, now to get common denominators, on the left one, I'm going to multiply by 3/3. On the right one, 2/2. This will give me negative 3/6 minus 2/6. This gives me negative 5/6. And again, if you don't like doing that fraction work by hand, you can type that into a calculator. So h of 1 is negative 5/6, and that's our answer. All right, number 7. We have a function g, our variable is x, and we need to plug in 9/7. So g of 9/7 equals negative 2/3 times 9/7 plus 7/4. This is the same thing as negative 2 times 9/7 times, or let me rewrite that. Negative 2 times 9/3 times 7 plus 7/4. I'm going to cancel my 3 and my 9, and that leaves a 3 on top. So this gives me negative, what does that give me? 6/7 plus 7/4. And those numbers are going to get pretty big, so I'm just going to type them in a calculator. So I'm going to say negative 6/7 plus 7/4, and that gives me 25/28. So if I were to write this as a function label, I would say g of 9/7 equals 25/28. And that would be my answer. All right, last up, function g, variable a. So I'm going to plug in 10/9. G of 10/9 equals 1 plus 3/2 times 10/9. I'm going to cancel my 2 and my 10. That gives me a 5 on top. I'm going to cancel my 3 and my 9. That gives me a 3 on bottom. So I'm really going to have, I think I miswrote this here. This here should be a plus, shouldn't it? So I'm going to have g of 10/9, or wait, I don't normally rewrite that. I apologize. I'm going to say 1 plus 5/3. There we are. Okay. Right, and my 5/3 came from this stuff here. That gave me my 5/3. Now I need common denominators. I'm going to change this 1 into 3/3 plus 5/3. This gives me 8/3. So my answer is going to be g of 10/9 equals 8/3. And that's that.